So, you know what? Let's start from the very beginning, right? Let's first talk about what is a data type, right? So, what is a data type? So, a data type is essentially a type which defines the nature or characteristic of your variable, right? Basically, it defines the characteristic or nature of the variable that you have declared, right? So, for example, if you want to store an integer, right? So you have to declare an integer, right? Something if you want to store something like money that you have or your roll number, right? In that case, you have to declare a data type that is an integer, right? Or in JavaScript, we call it a number, right? If you want to store, let's say, characters, right? Let's say A, B, C, or some string, right? In that case, you will declare a string, or in JavaScript, we call it character, right? Something like A, right? So this is a character, right? Let's say you want to store Boolean values, right? In that something like true or false, right? That is what we call Boolean, right? So all of these, this integer or a number, this character, these true or false, all of these have different nature when compared to one another, right? And that's why they define the characteristic or the nature of the variable that you have declared, and that is what we call a data type. A data type is nothing but something that defines the character or nature of your variable, right? There are other data types in JavaScript as well, like symbol or big integers, right? So I hope you all know that. Now, coming to something that we will hear a lot of, that is, what are data structures? So data structures are essentially a way to organize your data, right? A way to organize your data, right? So let's say you want to store a list of students that are in your class, right? So you can use an array, right? Or if you want a data structure which gives you a minimum value at the top, right? You can use heaps. So there are different data structures that we're going to study about throughout this course. But essentially, what a data structure is that it helps you to organize your data, right? It gives you several operations. What are those operations? Those are CRUD operations. C basically stands for create, R stands for read, U stands for update, and D stands for delete, right? So let's say if I want to store a bunch of names, right? I basically use a data structure that helps me first create those names. So let's say if I want to store the name Jim or Dwight or Pam, I should have a data structure that allows me to at least create these names, right? Next is read. So if I want to access any of these names, I should be allowed to. That is what we mean by read, right? Now, if we want to update, right? Let's say instead of Dwight, I want to save Andy. Then the data structure that I'm using should at least allow me to update my values, right? And then delete. So let's say I want to remove some name from a system. So let's say if I want to remove Pam completely from my system, so I should be able to. So every data structure should be able to give you these operations, that is create, read, update, and delete. So that is what a data structure does. It basically helps you organize your data by giving you some operations. Now coming on to the next part, that is algorithms, right? So algorithms are nothing but step-by-step procedure. What are they? Step-by-step procedure, right? So you would not know this, but actually use algorithms in your day-to-day life. Like let's say you want to make cold coffee, right? So in your mind, you have a step-by-step procedure that you follow to get a cold coffee, right? Let's say you want to go from your home to a park, then in your mind, you have a step-by-step procedure that you follow to get to the park. Those are essentially algorithms themselves. Basically, any step-by-step procedure that you follow is known as an algorithm, right? So you know what? Let's take, for example, baking a cake, right? So would anyone like to unmute themselves and try to tell me what would be the algorithm to bake a cake? Anyone? Any takers? Come on, let's keep this interactive. Feel free to speak out, whatever you want. No one? Okay, cool. Then I'll do it this time.
First
Okay.
is gather the raw materials.
Yeah, please go ahead. Please, yeah, because you guys are on mute, please, while you're speaking, first say your name and then start speaking. So I know who's speaking. Yeah, please, whoever. Chandani
Hi,
Kapoor has raised their hand.
Sekat here.
Yeah, bro, please.
First would be obviously to gather the raw materials.
Yeah.
They get to make a cake.
Yeah. Then next step. Okay.
The second would be, I guess, making the dough.
Making dough. Okay. Anybody else wants to take the third step? Someone raised their hand. I forgot who they were, but would they like to unmute themselves and tell the third step according to them? Whatever. We don't have to be Sanjeev Kapoor chef here. You can say anything.
Hi Ankush, this is Chandni.
Yeah, please.
Yeah, so we add the flavors like once we
Yeah.
prepare the
Yeah, okay.
yeah, and then we put that inside the oven.
Yeah, essentially bake inside
Oven.
oven, right? And
Yeah.
then you would finally get your cake.
Yeah, then we set the timings after
Yeah,
that.
that will come here, like setting the timings and stuff like that, right? Basically decorating as well.
Yeah.
We can take it in this step, right? And then you finally get your cake, right? So essentially, these are certain step-by-step procedures that you have to follow to get your cake. And this right here is actually an algorithm, right? That you first start with your raw materials, which in programming language you call as inputs, right? Then you make dough, and then you add flavors, and then you bake. These are all in programming what we call as processing, right? And then finally you get a cake, which is a final output. So can you see that how in your day-to-day life we actually use algorithms and how they can be beneficial? That we need a step-by-step procedure that can tell us what we need to do from the given inputs to get the final outputs, and we need to define what processing we actually need to do to get that final output, right? So this is what an algorithm is, nothing but step-by-step procedure in plain simple language. Mind it, guys, we are not talking about anything technical right here. We are just talking about plain English definition, right? So now there are some properties of algorithm. Now we are coming to technical part. In a computer science environment or in a data structure algorithms environment, algorithms have some properties. First, they should be correct. That is, they should have a certain degree of correctness, right? That is, like if you're following this step, you should at least get a cake. At least get a cake, right? Second, they should be adaptable. That is, if I want to make hundreds of cake, then it should not be the case that my oven actually goes wrong. It should not break in between. So it should be adaptable to different number of outputs, right? So all things should work, right? Then they should be efficient, right? Basically, we all are hungry, right? So we want an efficient algorithm so that we get the cake fastest, right? It should not take more time than it is required. So, for example, let's say if you heat your oven at 275 for 1 hour, instead, what you can do, you can maybe turn it at 345 for 45 minutes, right? So, right here, by increasing the temperature, we get more efficiency, right? So, our algorithm should be efficient, that it should be the best possible there is. And the last one is scalability. So scalability. That our algorithm should scale. That is, if I want to repeat this algorithm for 100 cakes or 1,000 cakes or 10,000 cakes, this should always work. It should not be like that, after making 50 cakes, it fails, right? That should not be the case. So it should be scalable, that it should work for 100 cakes as well. Okay, 100 cakes as well. So these are the 4 properties of an algorithm, that the algorithm should be correct, it should be adaptable to its environment, it should be efficient, and it should be scalable, right? Any doubts in this? Any doubts? Okay, let's move forward, right? So now question comes, hey, why do we actually need algorithm? Why do we need algorithm, right? And that is because, the code you write, right, that needs to be understood by the computer so that it can perform specific tasks. So via code, if you want your computer to perform certain tasks, you need to give him algorithm, right? You need to give them algorithms, right? So from code, if you want an output, right, you need to give your system an algorithm, right? So algorithms are there because the computer cannot understand plain English. That's why if via code, you need to give the step-by-step procedure so that they can give you output. So this is your system. So via code, you give an algo, or should I say step-by-step, step-by-step procedure to your system, which then gives you output, right? So that's why you need algorithm, because computers cannot understand plain English. So via code, you give them step-by-step procedures, which we now know that we call them algorithms, so that we can get an output. So that is all about, what we will be doing in this whole module. That, what we will learn about various data structures. We will learn about various algorithms, and we'll see how some algorithms are more efficient than others, right? So that is sort of what DSA means, data structures and algorithms. Basically, how you store your data and what algorithms can you apply on your data structures so that you get the output that you want. Any doubt in this whole part? Please feel free to unmute yourself and ask doubt if there is any. No doubt, no doubt, no doubt. Good. Okay, so if all of you are clear, then let's move on to our first data section of today. Yeah. So the first data structure of the day is arrays. Now, arrays are basically contiguous blocks of memory that are stored in your system, which can store in each block a data, right? So what this actually means, an array is something like this. Contiguous blocks of memory where you can store a number or a character or a Boolean value or anything that you like, right? They have indexes starting from 0, 1, 2, 3, and so on till the length of the array, right? So again, repeat, arrays are basically linear data structures that have contiguous blocks of memory in your system that can be accessed via the index which start from 0, right? So again, writing about the property, arrays are linear data structures that have contiguous blocks of memory, and have indexes, right? So basically, let's say if you want to store a bunch of students, roll number, then you can have an array something like this, 1, 2, 3, 4, and so on, right? If you want to store, as we saw above, names of people, right? Then you can have an array of string, right? So you can have Michael, you can have Sheldon, and so on, right? These both are arrays. This is a number array, and this is an array of strings, right? So this is what arrays is all about, right? So how do you actually declare arrays? So you use basically a keyword in JavaScript const, then you write the name of your array, right? So let's say I want office names, and then an equal to sign, which is the assignment operator, and then just square brackets, and then here you can mark your data. Another way is you can use a new keyword and an array, which is a constructor function to create an array, right? So this is just a syntax. I will discuss this in detail when we jump to code, which is in few seconds. But is array clear? Chandini Kapoor, please go ahead.
Hi Ankush. Yeah,
Yeah.
so we know that array always starts from 0. So I'm just curious to know why it always starts from 0, 0th index. Why
Yeah,
not
so
from
it's
1? Why always from 0? Yeah.
Yeah. So it's just a basic reference that the programmers have taken. So, you know, in insides of it, they have implemented in such a way that it starts from zero. There are various languages where the array are one indexed as well, right? So those languages do exist. But if you talk about languages like JavaScript or Java or C++, all of them are zero indexed arrays, right? That is, the counting always starts from zero, right? It's just a frame of reference, right? If you set the frame of reference as one, then your counting will be like 1, 2, 3, 4, 5. And if you set the frame of reference as zero, then your counting will be like 0, 1, 2, 3, 4, right? So it's just like how those authors of the language themselves decided to go ahead. Is that clear?
Okay, thank you.
Oh, no problem. Okay, any doubts in like this theoretical part of arrays, or can we move to the code? Bolo yaar, just speak up, speak up. If you have no doubts, speak up, right? Affirmations are good, right? Okay, so let's move to the code. Let me share my screen again. Yeah, I hope my screen is visible to all of you. Yes, cool, right? So let's start declaring arrays, right? So the first way is that you can simply call an array equals to and square brackets, right? And here, if I do 1, 2, 3, 4, you can see that I have an array, right? So if I console.log this array, I will get my array, right? Similarly, another way is so const array2 equals to new array, which is the constructor way. So you are basically calling the array constructor to form an array. And here you can give it values. So if you get a 1, 2, 4, right, it will create an array of these. Console.log array2, and it created an array. Fun fact about this method: if you use something like this, right? So if you do const array3 equals to new array, and here you only give it one parameter, that is like 4, then what this will do is it will create 4 blocks of empty memory, right? So if I now do console.log array3, it gives me 4 empty items, right? But if I now do 4, 1, it will give me an array of 4, 1, right? So something that you should know. This assign, so let me write this assign 4 empty blocks of memory. Now, now we know how to declare an array, but how do we actually access an element, right? So that is where those indexes come into play. So let's say if I want to access an element which is at the first index, so all I do is I write the name of the array, square brackets, and the index that I want to access, right? So I get 2 because at the index 1 the value is 2, right? Similarly here as well, it works the same way. If I want to here access the second index, I can simply write square brackets and it will give me 4 because at second index we have 4, right? Now, can anybody tell me what will happen if I do square brackets 2 here? Anybody wants to guess? You can write it in the chat. What value should it give me? Yeah, someone spoke up.
Undefined.
Undefined. Yeah, that is correct. So this right here will give me undefined. Why? Because although I have defined this block, I have not assigned it any value. That's why I got undefined. So that is how we declare arrays and access elements, right? So array also have a method called length. So you can basically do array3.length and it will give you the length of the array. So right now it's just 4 because we applied 4 units of contiguous blocks of memory, right? So we have an array3 of length. Now, what if I want to declare a 2D array, right? So let's see how do we declare 2D arrays. So 2D arrays are declared something like this. So array 2D, you simply make an array, and inside that array, you make another array, right? So if I do like 3, 1, 2, then 5, 4, 6, and then something like Ankush, with that my name. This right here is a 2D array, right? So if I now console.log array 2D, I get this, that every array has its elements, and then you get every row. So this is the first row, this is the second row, and this is the third row. And to access any element here, the formula that you should use is array 2D of row, column, right? Basically, if I do array 2D. So the first row, let's say I'm talking about the 0th row. And if I do like the second column or the second index column, so I should get 2. And here I got 2. Similarly, if I do like the second row and the first column, I get Ankush, right? So that is how you access a 2D array, basically the row and then the column, right? Then again, you can make like multi-dimensional arrays as well. So if I do multi-dimensional arrays, right? So for that, again, you can do the same thing. If I do array 3D, which is equal to an array inside an array inside an array. So if I put 1 here and then like 2 and then like 3. So this right here is a multi-dimensional array. So if let's say I do array of 3D of 0, let's see what we get. We get a 1, which in itself is an array. If I now have to access the element, again, I will do 0. And now I will get 1, right? So this is how you can derive multi-dimensional arrays as well in JavaScript. But this is all about arrays. Basically, how do you declare them? How do you access them? Any doubts here? Any doubts here, folks?
No.
Anything, guys?
So I have one question.
Yeah, please go ahead.
Like, is it okay to store like character strings in a single array only, or like?
Yeah. So this, if I talk about this array right here, right? If I seclude it and copy it here, this is what we call a homogeneous array. That is, in an array, all of your data types are the same. And in your data structure algorithms problem, you will only deal with homogeneous arrays, right? And when, as you correctly said, in an array, be it 1D, 2D, 3D, you have different types of data types. That is what we call a non-homogeneous array. That is, they have different data types. So we will never deal with non-homogeneous arrays. And also, it is not a best practice to have non-homogeneous arrays, right? I just wanted to show that they are possible.
Yeah.
But it is not a good practice to follow.
Yeah, thanks.
Cool. Just a thing, one suggestion. So like Prashant wrote all good. I would suggest everyone to write all good or no doubt when you have no doubts, right? Just a no really is ambiguous for me. So just write no doubt or all good, something like that, right? So that's a good practice, I think. All right. So now we know how to access arrays, how to declare them, and what they are, right? So let's solve our first problem, right? Let me comment all of this out, right? Let's say you are given an array of roll numbers, right? So roll numbers. So let's say 1, 3, 2, 4, 7, 6, 5. Let's remove 5, right? And you are given a key. Let's say right now 2. Can you guys think how can we, if I want to find, does this key exist in my roll numbers or not? How can I solve this problem? How can I search for this key in my roll numbers array? Take 2 minutes, think about it, and then if you have a solution, please feel free to speak up. But I would suggest everyone to take 2 minutes. How would you solve this problem? I'm repeating the problem again. You are given a key and an array. You want to find the index of this key in this array. If the index does not exist, print -1. If the index exists, print the index. That is the problem that we have. Anyway, please take 2 minutes to think about it. No worries. I'll start a timer for 2 minutes as well, so that it's only fair. 2 minutes timer. Think about it, and if you have enough, feel free to speak up. Also, if you for sure know the answer to this problem, because I assume some might, then I would suggest maybe you can skip this one or skip speaking this one. But if you are trying really for the first time, please feel free to speak up.
Ankush, could you please repeat the question? I mean,
yeah, sure.
now
My
change
pleasure.
the device. Yeah.
No problem, no worries. So I'm saying you are given an array of roll numbers, right? Which has all numbers 1, 3, 2, 4, 7, 6, like that. And you are given a key. Your task is to find the index of this key in your roll numbers array, right? If the key exists, print the roll number. If it does not exist, print -1. That is the task at hand.
Okay. So should we have to write the code in Visual
Just
Chat?
for now, just think of approach how would you approach this, right? Not saying the code, but how would you approach it? If you have to tell someone the algorithm for this in plain English, how would you tell it to them without using technical words?
Can I tell now?
Sure, please.
Okay. The basic brute force method is to compare each and every element and
Hmm.
check that whether that particular element was equal to the 2 or not, which
Yeah.
will take a brute force method.
Yeah,
And
cool.
another
Thanks.
somehow optimized
Mhm.
will take later because
Sorry.
as we already know that there will be some optimized methods as well, right? Like binary search, like
No, no,
dividing
no.
the
So
things into.
I'm assuming you knew that. So I think you missed that part. So first,
Mhm.
the approach is absolutely correct. Congrats on that. Right. Second, since you mentioned binary search, I'm assuming you knew this, right? So I just iterated for all students that if you for sure know what the answer is, you can skip to speak because that would hurt the ones who were trying. Because again, I'm kind of wrong. I'm
Sure,
assuming you
sure.
knew this, right?
That's a brute force method, which
Yeah, yeah.
I
So, and to just answer your point, binary search won't work in this question because the array is not sorted, right? So I don't want you to take anything wrong from this session. So I just want to tell you binary search won't work.
Mhm.
Cool. But yeah, your approach for linear search was absolutely correct. So, hi. So was everyone listening? Did everyone, sorry, what was your name? I missed your name. Hello?
Yes.
What was your name? I asked
I,
everyone
it,
to like, sorry?
I guess it was Charan.
Oh, my name.
Yeah, yeah.
Yeah, this is Charan.
Jay.
Charan.
Charan.
I'm sorry, I'm not able to hear. Can you type it in chat?
Mhm.
Charan. Okay, okay, Charan. Great. So, did everyone hear what Charan had to say? Would anyone else like to try if they want to speak up their approach?
What we can do is this is a linear search. The time complexity would be O of n. O of n. What we can do is we can put the elements of the array into the hash map and search for that particular element contains key.
Why would you put it in a hash map?
Okay, but yeah, but ideally that also won't make any sense. Yeah, then O of n would be the best complexity linear search.
Okay,
Uh,
okay, got it. Okay, guys. So let's look at the approach, right? So the approach which Charan suggested was that you have this key and you have this array. You don't have any preconceived notions about this array. So what you can do is you can go one element by one element and then check if this element, the current element that you're checking, matches with the key. If it does, then you can simply log that index. And if after traversing the whole array, you didn't find the element in that array, then you can simply print -1, right? So let me just show you using my tab. So I'll just share my screen. Yeah. So the problem is something like this. We have 1, 3, 2, 4, 5, 6. Yeah. So we basically have an array A, something like 1, 3, 4, 2, 7, 6. And we are given a key, let's say 4, right? Our task is to check, does this key exist in my array or not, right? So what we can do is we can loop over the array and we can check, hey, is this element equal to the key? If it is, then print the index or else move forward. Is 4 equal to 1? No, it is not. So we'll move forward. We'll come here. Hey, is 3 equal to 4? No, it is not. So we'll move forward. Then we'll come here. Hey, is 4 equal to 4? Yes, it is. So we'll simply print its index, which is equal to 2. So we'll print 2 and that would be our answer. Now let's say if the key was 5, right? And removing the other stuff, right? So first we came to 1 and we checked, hey, is this equal to my key? No, it is not. Hey, is 3 equal to my key? No, it is not. Hey, is 4 equal to my key? No, it is not. Hey, is 2 equal to my key? No, it is not. Hey, is 7 equal to my key? No, it is not. Hey, is 6 equal to my key? No, it is not. okay, I have traversed the entire array. That means this key does not exist in my array. So that means I will print -1 as my answer. So this is basically the approach. Any doubts in the approach? Any doubts in the approach? What we're going to do? Basically, we're going to loop over the entire array, and for each element, we'll check, hey, is this equal to my key? If the element is equal to my key, we will print the index, else we'll carry forward with my array.
Ankush,
Yeah.
just I think I misinterpret. So key is just a value, right? Data
Yeah.
and value, just a value, not like
Yeah.
that key and value. Be maybe I'm getting in that direction.
No. Key is just like your integer data type. It's just a variable of integer data type.
Okay.
Just a var key.
Okay. Thanks.
Cool. Okay. So let's try to code this out. So I hope my screen is viewing again. Right. So we'll make a function called linear search, which takes an array and it takes the key, right? And we'll loop over that array. So we'll do for let I equals to 0, I less than key, sorry, array dot length, I plus plus. If my current element or the ith element is equal to the key, you know what? Log my index I, and we can add the element as well, array of I, and then we can simply return that, you know what, my work here is done. Else, if after traversing the entire loop I never come to this if statement, that means I would have never returned. So I can simply write here console.log -1 element not found. Right. So I can basically call this function. So I can do linear search, where I can pass it my roll numbers, and I can pass it my key. Right. So let's see what happens. So we get 2, 2. That is, what was our key? Our key was 2, which is at the second index or the 2th index, I should say. The position is 3rd, but yeah, that is because of the 0-ish indexing problem. But essentially, the index is 2 and the value is 2. Let's try for a key, let's say 5. So we got -1 element not found, right? So this algorithm for traversing the entire array, trying to find the key, is what we call linear search. Linear basically meaning that one by one we go to each element, we check if it is equal to our key, and then if it is equal, we simply log out the index. Else we log out -1 if in the entire array we did not find the answer. Yes, Charan, go ahead.
Yeah. So are we using the JavaScript or the entire journey of DSA?
Sorry.
Are we using JavaScript throughout the journey of DSA?
Yes. Yeah. I hope that was communicated to all of you, right? We will be using JavaScript.
Yes,
No.
it was.
Okay. But yeah, for everyone's clarity, for DSA, to code out the solutions, we would be using JavaScript throughout the course. Alright.
Can we use another language like C++ or Java?
That would be a hard no. What I have been instructed. So we would be using JavaScript. I believe you guys are learning backend in Node.js. So I believe that would be like very complementary to each other. So that's why we have chosen JavaScript as a language.
Okay.
Cool. So someone asked, can we use includes? So includes is basically a prototype function of arrays that tells you whether this element exists in the array or not. It essentially, I believe, gives the Boolean value rather than the index, right? But this imposes a very important question, right? What do you think about the pre-built methods that you have in an array, right? And as far as your data structure interviews goes, DSA interviews go, there I would highly recommend not using pre-built function, or at least not solely being dependent on these inbuilt functions, because the interviewer can really ask you, hey, do you know the inner implementation of these? So while they are good to know, I would highly suggest that you know the inner implementation of those functions as well, right? So Neha, I hope your doubt is answered. All right. So if everyone is clear with this problem, let's try another. So let's say you are given a 2D array, right? So let's say you have money in bank, right? And it is a 2D array. So somewhere you have 10, 20, 30. Then you have like 10, 100, 1,000. And then you have like 20, 21, and 22. I want you to write an algorithm or a procedure such that you get the money in all of the accounts, right? So essentially each index represents money in an account. I want you to find the total money that is in the bank, right? So for this problem, the answer would be 10 plus 20 plus 30, that is 60. Then 60 plus what? So let's write it down. So 60 plus 1, I believe 10 plus 20, 21, 22. So that would be 63. So 63, right? So what does that equal to? So that is equal to how much? 123 plus 1110. So that is equal to 1, 2, 3. No, 1, 2, 3, 3. Yeah. So that should be the output for this problem. 3, 3, 2, 1. Yeah. So that should be the output for this problem, right? Again, I'm repeating. You are given a money in the bank in form of 2D array. What I want you to do is I want you to write a function that returns the total money in the bank, which is the sum of all the money in each account, right? For this case, it would be 1, 2, 3, 3. Again, take 2 to 5 minutes and think about how you can do this, how you can approach this. Take your time, everyone. So we do have one approach in the chat box. Anyone else, if thought of something, please let me know. If you have anything, do let me know. And I would really suggest anyone to speak up and converse with me that, hey, I'm thinking of this and this is why I'm thinking of this, because in a technical interview, that is what will be expected of you, to converse with your interviewer, right? So if anyone wants to tell me the approach without using any technical words, I would love that.
Yeah, Ankush.
Yeah, please say your name first and then your approach.
Sorry.
Please say your name first, your name, and then
Yeah.
whatever you want
Okay.
to do.
This. Yeah. So this is Charan.
Oh, okay, hi, Charan.
Yeah. So the approach is similar to the linear search, taking each and every subarray. So and adding every element on each iteration into the global variable called sum. So in that case, we're going to take two nested for loops. At the last, at the inner for loop, we're going to add each and every element into the sum variable, and finally, outside both of the loops, we're just going to print it.
Got it. Yeah, that approach is fine. Absolutely correct. Yeah. So anyone else wants to speak up? If they have anything in mind, please feel free to speak up. Anyone else? I'll wait for another 30 seconds.
Hi, Ankush. This is Mohammed.
Yeah, hi,
Okay. One approach I think it is actually a very similar one, but like first I would sum each accounts, then I will take the sum of all the accounts. So
yeah, that is absolutely correct. So essentially what everyone is saying, you know what, we need to traverse each row by row, and during each row we need to calculate all of these sum together. So that will be my total money in the bank, right? And to do that, all we need to do is we need to just loop over the entire 2D array and make a global variable total sum, which will store the sum that I accumulated till now, right? So if I show you, let's make a function called money total money in bank, which takes the money, which takes, let's say, bank, right? And the job of this function is to return the total money, right? So for like, so we can make a variable let dimension d is equal to bank dot length, right? And since this is a square matrix, both the number of rows and number of column will be same, right? So for let I equals to 0, I less than d, I plus plus. For let j equal to 0, j less than d, j plus plus. This, and let total money initially equal to 0, right? Now in each iteration we do total money plus equal to bank of I comma j, right? Now what this exactly does is, for each row and in each row, each column, it accesses that row comma column for me currently, right? That I comma j. I will show you in the diagram what is happening right here, but that is what it is doing. And then finally, we can return total money, right? So let's just check it out if it is working or not. So, or we can call it out. Yeah, let's just return it. So we can console.log total money in bank, and then we can have money in bank. So if I log this, I get 1233, right? Now let me just go back to my iPad and show you a dry run of what is actually happening. Okay. So again, I gave you this time a 2D array, right? Which was something like 1, 2, 3, 10, 20, 30, or 10, 100, or something like this, right? I don't remember it exactly, but that's what it was. So if I talk about the row indexing, it was something like 0, 1, 2. If I talk about the column indexing, it was something like 0, 1, 2. So our approach was, for each row, calculate the total sum of each column, right? So for row 0, I needed to go from column 0 till column 2, right? Then again for row equal to 1, I again needed to go from column 0 till 2. Then for row 2, I again needed to go from column of 0 equal to 2. So can't I say that this whole actually represents, for row 0 till 2, I need to go from column 0 till 2. And in each step, whatever that matrix of row comma column I have, I need to add it to my total sum. Right? So this basically, this nesting of loops helps me access each and every element in my matrix, and then I'm just making a variable that holds the sum or total sum of all of these values, and then I'm finally returning that sum. So if I go through a dry run of my algorithm, so initially row equal to 0, then at column equal to 0, I have my t sum equal to 0, right? So I access the first element, which is at 0, 0. So that is 1. So I add 1. Then I add, increment my column to 1, right? So I get 2. So I do plus 2. Then I increment it to 3. So I get plus 3. So this whole is equal to 6, right? Then when this loop is ended, I will make it to 0 again, and I will increment my row, which now becomes 1. So I add 10. So this becomes plus 10, right? Then I increment my column. So column becomes 1. So I pick this element 1, comma 1. So that is 20. Then I again increment my column to 2. So that becomes 30, right? So now this is done. So this becomes 0 and row becomes 2. And my total sum right now is 66. So at this point, I pick this element 2, comma 0. So I add 10, right? Similarly, this becomes 10, 1. So I add 100. Yeah. Right. And then this becomes 2. And then I pick this 100 again. So I add another 100, right? So this total in turn becomes 200 plus 76. So 276. So 276, which is my final output, right? So I hope that the approach that we took is clear to everyone. Any doubts? Ravi Raj says, can we use map? So first of all, the answer to your question is no. Map will not help to reduce time complexity. Second, we can discuss more about why when we read about hash maps, right? But to answer your question, Ravi Raj, no, we cannot use maps here to reduce the time complexity. And we will, the next topic right here is what is time complexity, right? So we'll come to that. But to answer your question, no, the complexity won't decrease using maps. Any doubts? Anyone wants to speak up? Any doubts? Any queries? Any queries in the code? Anyone? Any problem? No doubt, no doubt. Cool, cool. Great. Okay, just a quick feedback. Up till this point, do you find the pace to be very fast, very slow, or is it good enough? Let me know if the pace is correct or you want me to slow down or fast enough. Anyone? Good enough, good enough. Perfect. Great, great. Great, guys. You guys are awesome. I'm loving your energy, right? So now, the stuff that someone asked, what was the name? I want to get the name correct. Ravi Raj. So Ravi Raj gave us an intro to a very interesting topic, which is one topic that if I'm an interviewer, I will always grill you upon, and that is time and space complexity. Right. So time and space complexity are nothing but the relation between your code and its performance, right? So, when we talked about algorithms, I talked about 4 points. First was correctness. Then was adaptability. If I want to test a code's correctness and adaptability, I can do it using a bunch of inputs and outputs, right? I can basically write like the 2 problems that we just saw. I can give it a bunch of inputs and check it across bunch of outputs. And I can say if my code is correct and adaptable or not. Do you guys agree? That using some test cases of inputs and outputs, I can check if my code is correctable or adaptable or not. Yeah, cool. But what if I have to check the efficiency and scalability of my code? Scalability. Then how do I do that? To do just this, we have time and space complexity. They are nothing but the relation between your code and the resources, that is in terms of time and space that it utilizes, right? Time and space complexity define the relation between your code, that if you change the inputs, this much more time it will take, or this is how the time will scale. That is what it defines, right? So basically, based on inputs and outputs, how your code will scale, that is defined by time and space complexity. So we need raise the hand.
Yeah, hi. Just wanted to. I'm just confused about how you measure adaptability.
Okay,
just-
cool. Yeah. So basically, let's say in our linear search code, what if the code breaks at when your array of the size 10 to the power 3, right? Which is not happening in our code. But let's say you are hard coding, you're looping till a certain number, right? Let's say instead of going till length, you're only going till 1,000, right? So let's say if you get the size more than 1,000, what your code will break, right? Because it will say that, hey, I don't know if this exists or not. Does that make sense?
Okay, thank you.
Right. So for different inputs, it should adapt to them, right? So that is what I mean by adaptability.
Thank you.
Yeah, cool. Right. So basically, based on your inputs and output, how your code will scale, or basically how much more resources it will require in terms of time and space, is defined by time and space complexity. And that's why it helps us measure efficiency and scalability, right? So let's go back to our example of cake for algorithm that we took, right here, right? So let's say for making a cake, let's say it takes us 5 seconds to do all the 4-5 steps that we defined, right? It takes us 5 seconds. And let's say if I want to make 1,000 cakes, then the total time would be 5 into 1,000 seconds equal to 5,000 seconds. So if I want to tell this via a relationship, right? Can I say that total time is dependent actually? So let's say it takes k seconds to make a cake, which is actually 5, and I have to make n number of cakes, which are currently 1,000. Can I say the total time is actually dependent on n times k? That time it takes to make a cake, time for each cake, and the number of cakes that I have to prepare, number of cakes, right? The total time will depend on n and k both, right? So basically, now I know if I have to make n number of cakes, how much time can I anticipate? How much resources will making n cakes involve, right? Consuming each cake takes k time. Does that make sense? I think I stumbled a bit, but does that make sense? That, you know what? Instead of using these constants, I am actually giving a mathematical equation that how making a cake, if I have to make n cakes, how that algorithm will actually progress. It will depend on both the time it takes to make a cake and the number of cakes I have to make. It is dependent on both. Does that make sense to you? Do I have to repeat? Please, if there is anyone who wants to repeat this part, that what is this n times k, I will. Please say, please. All good? Please, okay, please repeat it. Good. Okay, Nitin. So I'm saying that, you know what? Time and space complexity are just a tool so that I can measure the efficiency and scalability of my algorithms, right? So I went back to my example of making a cake. I'm saying, let's say the amount or the time it takes to make a single cake is 5 seconds. Let's represent by that variable k, that it takes k seconds to make a cake, which in our case is 5. And let's say I want to make 1,000 cakes, which in our case I'm assigning a variable n. So can I say that the total time to make n cakes is equal to n times k? And can I say that this equation actually represents the total time it will take to make n cakes? And can I say that it is dependent on number of cakes I have to make and the time it takes to make a cake? Can I say that? Yeah. So that is essentially how you define the complexity, that based on the inputs that you have and the output that you want, how can I tell someone that how my algorithm will scale, how my algorithm will work, right? Basically what this tells us, I'll tell you in a second, like graphically it looks something like this. So if I want to make 1 cake, it will take 5 seconds. If I want to make 2 cakes, it will give me 10 seconds. So it follows a curve something like this. So to be able to predict at what inputs, what amount of resource I will be utilizing, we use time and space complexity for our help. Cool, right? So let's understand how do we actually represent our time complexity. So to represent a time complexity, we use the big O notation, right? So big O notation basically calculates your time complexity for the worst case, right? What is the worst case? That, you know what, the maximum amount of time or resources I would need according to my algorithm, I will account for that. That is what big O represents, right? So to write a big O notation, all you write is a big O and then brackets. And here you write a complexity. So if I have to write the complexity of building n cakes, where each cake takes k time, my time complexity in terms of big O would be big O of n times k, where n is the number of cakes and k is the amount of each cake, or time for each cake, time for single cake. This is how I would represent time complexity in big O notation. Any doubts? Any doubts? Cool. Right. So there are certain rules for the big O notation, right? First, obviously, always account for worst case time complexity or space complexity in terms of big O notation. Second, ignore constants / small values. Let's understand each one by one, right? Now, what is this worst case? You know, above all this, I said worst case. What actually is this worst case, right? So during your DSA journey, you will encounter 3 types of cases: best case, average case, and worst case. If I bring my example of, Dheeraj, I'll take your doubt in just in a second. Just let me finish this average, best, and worst case. So if I bring out my example of the array that by linear search, right? So let's say 1, 4, 6, 2, 3, 8, right? And my key is, right? So can you suggest what would be the key if I want to find the best case in terms of average case and in terms of worst case? Can I say that my key in worst case would be a key that does not exist in the array? Because then I would have to traverse the entire array, right? So it can be 9. Because if my key is 9, then that is a worst case for me, because I will have to do the maximum number of computations, right? So case where you need to do max number of computations is known as the worst case, right? Then the best case is, as you can guess by now, the case where you need to do the least number of computations. So minimum number of computation, right? So if my key was 1, then I would start the loop from 0 till x, and at the first iteration only I will get the key, right? So key equal to 1 is my best case. That, you know what, I only do 1 iteration and I get my answer, right? And then average case is anything in between, right? So if the, your keys were somewhere between 4, 6, 2, 3, that would sort of be your average case, right? So that is what each case means, that, how many computations do you have to do? And to tell about the time complexity of your algorithm, you should always consider worst case, because you should always be prepared for the worst case scenario, right? But that is what each case is: best case, average case, and worst case, right? So in terms of linear search, right, can I say that the worst case is big O of n, because where n denotes the size of the array, so n is the size of the array. Because I don't know, key can be anything, right? It can be any number. So in that case, I will have to traverse the entire array, right? Does that make sense? Yeah. Dheeraj, now you can ask your doubt, and yeah. Dheeraj?
Yeah.
Yeah.
Hi, Ankush.
Yeah,
Okay.
please.
So I guess we have 3 types of notation: big omega notation, theta, and O notation. So
Yeah.
why we use most of the time big O notation rather than using those 2?
So very good question and very relevant question right now. So worst case actually is big O notation. Theta is, I believe, average case, and omega is, I believe, the best case. Now, to calculate your average case and best case, it is always not very trivial, right? So when we come to your algorithms like graph algorithms or dynamic programming algorithms, at that time, it is really hard to tell what is your best case and average case and how would you actually quantify it, right? So this requires a lot of calculus, right? And your interviewers themselves might not know these best case and average cases, right? And worst case is really easy to predict. And we should always, like from a computer science mindset, we should always build on the worst case, right? So the answer to your problem or your query is that worst case is easy to calculate, and that is the most relevant, right? So that is what you will be tackling throughout your interviews. No one in your interview will ever ask you the best or average case, right? They might ask you cases that what could be the best case or average case, but in terms of time complexity, no one will ever ask you what is the best case time case complexity or average case time complexity. I hope that answers your question.
Yeah, sure. Thank you.
Yeah. Any doubt in best case, average case, and worst case, and what would be the best, worst, and average case for your linear search? Is everyone clear with this example? Yes, you can put your hand up. Any doubts? Okay, so let's move on to the second point, which is ignore. I'm so sorry. Yeah, which is ignore constants and small value, right? Now, this is also very important because we are talking about worst case. There's a rule that, what, if k times n is your algorithm and k is much, much smaller than n, then it won't make a difference in your sort of time complexity, right? Basically, n, 2n, 3n are sort of the same thing, right? In big O notation, right? That's why if I say that, what, in our cake example, where our time complexity was n into k, if I say that this k will always remain constant, it will never change, right? So can I say then my time complexity is actually independent of k, and I can actually remove that, and now my time complexity only depends on big O of n. If I say that k is a constant, that 5 seconds will never change. So can I say that to build n cakes, now my time complexity is dependent of O of n. That is the number of cakes that I have to build. Does that make sense? Again, because time complexity is not equal to total time taken. It is basically the relation how your algorithm will scale, right? So since I'm saying that time to bake each cake will always remain constant, it will never change, can I say then the only variating factor is n, and hence to bake n cakes, my algorithm will depend only on n. If I want to bake 100 cakes, then it will take 100 times k time, but k is constant. Does it make sense? Anyone? Why do we remove constants? Anyone who did not understand this one, that why did we remove constants? Anyone? Anyone? All right. So that is the second rule, that ignore constants or small values because they would not account or change your time complexity, right? So these are the few rules for time complexity. So again, reiterating, time and space complexity are just the relation between your code and the resources that you utilize, and they are dependent on the input to give the output, right? Basically, they're highly dependent on the inputs that you give to the code, right? Based on those, you tell your time and space complexity, right? And yeah, so this was the example that we saw, and I hope everyone understands what a best case, average case, and worst case is. If k is equal to n, we should, yes, Nathan. If k is greater than n, then we should definitely consider it, because it is a significant amount of thing that will contribute to my time, right? So let's say if n was equal to 10,000, right, and k is equal to 1,000, then if your complexity is n into k, then it really adds, that k really adds. But if your k is just equal to 10, then and that n into k won't make a difference, right? So it's relatively, you have to check what is bigger and by how much. Okay. So is everyone clear up till now? So up till now, I'm just recapping. We discussed about data, discussed about data types. We discussed about data structures, algorithms. We discussed arrays and different algorithm of arrays and how do we actually quantify uh, your time complexity. And then we saw that how we quantify the time complexity of linear search. Is that clear? Any doubt till now? Any part? If there is any doubt, please let me know. Yeah. Okay, great. Are you guys good to go? You want a 5-10 minutes break? Or can we move forward? Does anyone need any break or can we move forward? Please let me know. This is a small 5-10 minutes break. If you don't need, we can move forward. We can move forward. Great. Okay. So now that we are clear with every time complexity and everything, let's try our first problem, a real problem, right? So the name of the problem, yeah. So the name of the problem is sort 0 and 1. And what this problem basically says is you are given an array which only contains two numbers 0 and 1, right? So something like 1 0 0 1 0 1, right? And what you have to do is you have to sort them. Sort means increasing the array in increasing order, right? So the output should look something like 0 0 0 1 1 1. This should be the output, right? So can you think of an algorithm that we should follow to get this output? So this is your problem. You are given this array. You have to sort this such that it looks something like this. And that's what you have to do. Take time, take 5 minutes, right? I'll start our clock for 5 minutes and let's discuss the approach there. Timer. Yeah. So take 5 minutes. It's okay. Think about the problem. If you want me to repeat the problem, let me know. Basically, you're given an array which only has 0 and 1s, and your task is to sort that array. You have to come up with an algorithm that does this and think. Take 5 minutes and think. Meanwhile, I'll just take a minute to refill my water bottle. I'll be back in just a minute, guys. Thank you. Go ahead.
Since we have only two numbers, 0 and 1, we can have two variables and we can simply count the number of occurrences of zeros and 1. And then we can run a for loop. And according to the count, we can just fill first zeros and then the left are 1.
Correct. Absolutely correct. Anyone else? Any other approach?
The other approach is like two-pointer approach. Maybe not a good time to discuss, I guess.
Okay. Anyone else? Anyone else wants to try any other approach? Speak up, guys. Speak up. Whatever you're thinking, speak up.
Yeah, the same approach I'm going to do from that like 2-pointer. So let's consider x and y. X initially x and y both under the same starting position, and we're moving the y position onwards.
So you're saying you will consider 2 pointers x and y initially both at starting. Yeah.
And we're moving the y pointer. So whenever the y position value is 0, we're just swapping the values at x and y.
Okay.
And just remaining the position of x to the new position of the y.
How would you update them?
Sorry?
How would you update these positions?
The positions. Yeah. I mean, x would be replaced with y, and then y move onwards.
Okay, let me give you a scenario, right? So let's take this scenario only. We have 1 0 0 1 0 1. You are saying that initially both will be at x comma y, right? You're saying then whenever y is equal to 1, you swap with x. Is that what you said?
No, whenever we find 0, we're just swapping it.
Okay, and but if we don't find 0?
Then it should be, it will, I mean, go onwards.
Okay,
Onto the
so
next iteration.
we didn't find 0 here, so we went forward, right? Now it's a 0. Now you want this to swap, right?
Yeah, swap 0 to the 1.
Okay.
And the positions also of the x would be changed with the position of y.
Okay, so
And-
now x comes here.
Yeah.
And now what?
And y go onwards.
Okay, so
The
now
next iteration.
y comes here, and
Yeah.
now what you want?
Again, swap them.
Okay, so we make it 0 and we make it 1. Now,
Yeah, and x would be at a y position, and y will move onwards to the next
Okay.
iteration.
okay, now here's a 1 and here's a 1 as well. What do we do now?
Yeah, we do not need. So again, y will go to the next iteration to the 0.
Okay,
So and then swap the positions with that.
okay, 0.
So x would be at the place of y, and y will
Mhm.
move onwards.
Okay, tell me this.
Mhm.
What will happen in this space?
On
No,
0.
yeah, x comma y.
Okay. Since y will go till the first it is 0, and it will swap to the first position.
Mhm.
And then again, y will go to the next second 0, and it will swap with. Okay, in that case, it will.
It will fail.
Yes.
Ankush, I
Yeah.
guess there is a catch in this approach.
Yeah.
The pointer should be on the 0th and the first index, I guess.
Okay,
Then
okay.
it will work.
No. It won't, because he was saying that y is equal to 1, just keep moving forward, right?
No,
Even
no.
if I started initially, then like y comes here, right?
Approach is like we keep the, let's say, x and y. So we
Mhm.
keep the x pointer at 0 and y pointer at 1. Whenever I encounter a
When
0,
what do you mean by 1? Do you mean the index, or what do you mean?
sorry,
By 1, you mean the index 1, or what do you mean?
no, value. Whenever okay,
But how do you
index
know?
1,
You don't know about the array, right?
index 1.
Okay, index 1. Okay.
Uh,
Okay, so right now
uh,
it's your case, right? X at 0, y at 1.
yeah.
Yeah, tell me what to do.
Whenever I will encounter a 0
Mhm.
on y,
Whenever
like
what pointer will encounter a 0?
whenever y pointer will encounter a 0,
Mhm.
and my x is at 1, okay,
Mhm.
so I will swap.
Wait. Whenever, I'm sorry, can you repeat that? Whenever y encounters what?
See, there will be a 3 if else statement. If my x
No,
pointer is
don't take the code. Tell me whenever y. So when, let's say when y encounters 1, what do you want me to do?
I will check is my x pointer is at no. Whenever my y pointer will encounter a 0, not 1,
Mhm.
I will check is my x pointer at 1,
X at 1, by x at 1, you mean
value.
x's value at 1 or index at 1?
X index value is 1.
X index value. मतलब basically point value being pointed by x, is that 1 or
मतलब
not?
वैल्यू x जिससे उस पे पॉइंट कर रहा है उसकी वैल्यू.
हाँ, ठीक है, x equal to 1 or not. Okay, then.
ओके, हाँ, तो अगर ये केस है तो मैं स्वैप कर दूंगा. I'll swap
Okay, I'll
x and y.
swap x comma y.
X and
Okay,
y.
ठीक
Okay.
है. And what if
my
y equals to 1?
if my y is 1, simply I will move forward.
Okay, ठीक है, करके देख लेते हैं एक बार. Right now you'll move forward, right? So you will come here. Then your y will come here, right? Now you check, hey, is x equal to 1? Yes. Swap x and y. So this becomes 0, and this becomes y, right? Now what?
Correct. If my x is 0, I will move forward.
Okay. Okay.
In this case, my y is 1. I have to move forward.
Okay. I'll move forward. Now you are here.
It will match the first condition. X at 1, y at 0. I will swap.
Okay. You made it 0 and 1. Now what?
I will move forward.
Okay. X.
Both pointers.
Okay. Both pointer Y. Here.
Okay. Still, it will match the first case. So again, I will swap. I will increment both pointers.
Okay. Here, and then you'll again swap and then go forward. So yeah, this
Yes.
this will work in this case. Did you try it for this test case? This 0011?
Okay. Yeah, I guess it will work for all the cases.
I don't think. Let me just think where it will fail.
Okay,
So
okay.
it will fail. It will definitely fail on one of the test case. Let me just think about it. I'll give you the test case. You can like try it. But I think this
Okay,
will fail. I don't think this will work perfectly. It is very close, but I don't think this will work perfectly because of the observation that I'm just going to tell you. We'll compare the values with 0. Okay. Let me check the time. Okay, the time is done. Okay. Cool. Who told this approach? This one. What was the name?
Dheeraj.
Oh, okay. Hi, Dhiraj. So, bro, check for it. I think this will fail. I'm not very 100% sure this would work all of the time. I maybe in the next class I can give you a test case where it might fail, but it might also work. But I'm not sure 100%, and that is because of the thing that I'm just going to say. Okay, guys. So let's try out what is our approach. So tell me something. Can I say, my array after being sorted would look something like a bunch of zeros and then a bunch of ones, right? Till some point, let's say m, there would be all zeros from 0 till m index. And from m plus 1 index, there will be all ones till n minus 1. That is the length of the array, right? Let's say that the n is the length of the array, right? Can I say that? Can you guys observe that after being sorted, my array would look something like this? That you know what? There will be a bunch of zeros in the beginning, followed by a bunch of ones. Does that make sense to everyone? Does that make sense to everyone? Yep, cool. So can I say that you know what? I can assume that you know what, my array actually looks something like this. I will have a start pointer and an end pointer, and what I keep as a base condition is that every element between 0 till s minus 1 should be a 0, and every element from e plus 1 till n minus 1 will be a 1. Basically, I'm saying if I have an array something like 0, 0, 0 till s minus 1, then I have a bunch of 1, 0, 1, 0 mixing, and then a bunch of ones from e plus 1 till further. Then all I need to do is I need to solve for the range between s and e. I'm assuming that every value between the index 0 to s minus 1 is a 0, and between e plus 1 till n minus 1 is a 1. Then my array would look something like this: a bunch of zeros, a bunch of ones, and now I have to solve for this 1, 0, 1, 0. I'm taking that, hey, my problem looks something like this. Right? So now tell me, if I'm at start pointer, yeah. Let me change the color. So if I'm at start pointer, right? Initially, it is pointing to 1. What can I do according to the assumption right here this that I have made, that you know what, I don't break this assumption. Can I say that you know what, till e plus 1 till end are ones, right? So and e must be a 0 value, right? Because I'm saying that you know what, if E was in itself 1, then I would have counted it in itself only, right? I would have extended that range. So I know that my E is a 0 and I know that my S is a 1. So if I swap both of these, what will happen, right? Initially, I have 1, 0, 1, 0, and a bunch of ones. This is my E, this is my S. If I swap these out, this now becomes all ones, and this now becomes all zeros, because I'm saying all the elements behind my S pointer are zeros. That is my assumption right here. And all elements after my E are 1. So I can say that my E can also come here and my S can come here. Basically, my S pointer can come towards the right and my E pointers can come towards the left, right? Because I'm saying that every element from 0 till S minus 1 is a 0, and all the elements from E plus 1 till N minus 1 is a 1. Does this make sense to you?
Hi, Ankush, can you please explain that assumption again? Like, where is that assumption stemming from? And you
Yeah,
did explain like
sure.
0 to M and then M plus 1 to N is
Yeah.
like 0.
So
But
I'm saying, can we observe that, you know what, if my array is sorted, then there will be a bunch of zeros followed by a bunch of ones. So there
Sure.
would be some index M. It can be of any value. I'm not concerned with the value. It can be 0, 1, 2, 3, anything. That would have a bunch of zeros. And then after that, after the last 0, all would be ones. So basically from M plus 1 till N minus 1, all would be 1. Can you just observe this pattern that after array being sorted, that would be the case? For example, here till 0, 1, 2, till 2, all are zeros, and after 3, all are ones. That is all I'm saying. That after being sorted, my array would look something like this. Does
correct.
that make sense?
Yeah.
Right. So I'm assuming that, you know what, my array, I'm assuming that this is my condition, that currently my array is something like this. That from 0 till S, I will make 2 pointers, where S is initially at the start and E is initially at the end, which is N minus 1. And I'm saying that my array should look something like this, and I'm assuming that configuration of my array is something like this, that from 0 till S minus 1, there are a bunch of zeros, right? So this represents that, a bunch of zeros. And from E plus 1 till N minus 1, that is the end of the array, there are a bunch of ones. So that represents this. And now all I need to do is I need to sort my array for this one, for the between the ranges of S and E. That is what I have to do. Does that make sense?
No, that still went over my head. Sorry.
Okay, no
But,
problem, no worries, no worries.
Are you assuming this on a sorted array or a non-sorted array?
This I'm assuming on a non-sorted array,
Okay.
right? And I will make sure to make this condition true in every case. That, you know what, I have 2 pointers and I'm saying from 0 till S minus 1, I will have all zeros, until E plus 1 till N minus 1, I will have all ones. And I'm assuming this because I know at the end of this, I have my array something like this, that there are a bunch of zeros followed by a bunch of M's. So I'm just saying that, let's say I have a configuration where I have a bunch of zeros in the start and a bunch of M's in a bunch of ones in the end. And in between there is this jumble. I want to solve for this jumble. That is my to-do. That is all I'm saying. Does that make sense now?
Yeah.
Okay. Someone raised their hand. Can they ask their doubt? Someone did raise their hand. Someone
It's
is
me. Yeah, it's me, Sam.
Oh, yeah, hi.
I did understand the zeroth part, but when you wrote like E plus 1, how are you making that assumption?
I'm assuming just like
I thought it would be S plus 1.
no. This is E plus 1, right? Basically, after my end pointer, I'm assuming there are a bunch of ones.
Yeah. If I say E is N minus 1, if I say E plus 1 equals where there is E, if I replace it with N minus 1,
that is
then
basically
it
going
would
out of
be
bounds, you are
N2.
saying, right?
Yeah.
Yeah. So we can assume that if out of bounds is always true, like we don't need to concern about like E plus 1 being out of bounds. Similarly, we also don't need to be concerned about S minus 1 being out of bounds, right? Because can't I say, like, let's say if I have this above array, right? Here S minus 1, I can say, right, it is true because I don't have to be concerned about this. Does that make sense? That even S minus 1 can be a minus 1 value, right? basically going out of bounds. Similarly, e plus 1 can also go out of bounds. So I'm saying it doesn't matter if they're out of bounds. I don't care about that because that will not affect my answer.
Okay.
Guys,
Sure.
I can
Thank you.
understand coming first time into this might look like what is happening. I'm just saying I'm assuming this, and the out of bounds value I'm not concerned with because that will not affect my answer. Does that make sense?
Okay. Sure. Yeah.
Right.
Sure.
Okay. So let me redraw everything. Right. So let me change the color now. Okay. So I'm saying I have a bunch of zeros and I have a bunch of ones, right? This is the SN minus 1 index. This is the E plus 1 index, right? And in between, I have these 1, 0, 1, 0, 1, let's say, or let's say 0. Let's know this, let's distance them. So 1,
Oh.
0.
Ankush,
Yeah.
is it the input array you're taking, like starting with these kind of zeros and in the middle only we're getting some subtle values?
Sorry. Sorry.
I mean,
Repeat.
is it the input value, input array you are taking?
This right here?
Yeah.
No. This is just my case. I'm just showing you one of the cases. I'm saying that let's say I come to a case where till S minus 1 index I have all zeros, and till E plus 1 I have all ones, and this I have to do for. Let's say this is just a case that I come for. This is not a one-to-one representation of my input array. Don't worry, I'll show you the approaches with the above array as well. Just I'm trying to make what operations I need to do. What is basically my approach? That is what I'm trying to define here.
So our ultimate goal would be to find S and E indexes.
No, not to find. We will always know where S and E are. Our main goal would be what do we do when we are at these indexes? So let's say if S points to 0, what do we need to do in that case? If E points to 1, what do we need to do in that case? If S points to 0 and E points to 1, what do we need to do there? And if S points to 1 and E points to 0, what do we need to do there? That is the only 4 cases, right? S can point to 0 and 1, E can point to 0 and 1, and what do we do in these cases, right?
So I mean to bring them adjacent is our goal, I guess. S and E's.
Our goal is to solve for this S comma E range, and that is what we'll see how we can do that.
Okay.
Okay, leave everything. Just tell me, is this assumption and this pictorial representation clear to everyone or not? Just this part. Is it not clear?
Yes.
Okay. Right. So now tell me, S is E holding at 1 and E is holding at 0. Can I say that, you know what, if I swap these values, then then I can actually shrink my range. Basically, if 1 goes here, right, then I can say that, you know what, I always want to make sure that E plus 1 till end are always 1. So I can shrink my E here. And I said that 0 till S minus 1 should always be 0. Then I can, and now 0 holds here. So I can simply move my S in front. Does this operation make sense? Why we swap? When S is at 1 and E is at 0, then swapping S and E and incrementing S and E minus minus is the move. Does this make sense? Does this operation make sense, guys? Any doubt here? What we did and why we shifted these pointers? Any doubt? Anyone? Okay. Now, what should we do when S is equal to 0? Can I say that I have assumed that everything till S minus 1 is a 0? So if I increment S, then this statement will again hold true because I have 0 itself. So right now, if I move my S pointer forward, you know, again, my property that everything behind till S minus 1 is 0 still holds true. Does this make sense? Does this make sense? Right? And if end is equal to 1, right? Then can I say that I know that everything from e plus 1 till end is a 1. So if I decrement my e pointer, that would also make sense. So end would come here, because everything from e plus 1 till end is also a 1.
But it could also be 0, no?
Yeah, so okay. So if end is 0, then so you are basically talking about when end is equal to 0 and s equal to 1, right? Tell me this, right? I know what to do when s is 0, irrespective of value of e. I know what to do with end equals to 1, irrespective of value of s, right? So the only case that is left is when end is 0 and s is 1, right? Because if end is equal to 0, and which case is left, right? Basically we have covered 0, 1. Basically, if 0, 0, right? If both s equal to 0 and n equal to 0, it doesn't matter the value of end. I have an operation to do, which is I will move s forward, right? And if s is equal to 0 or 1 and end is equal to 1, I know irrespective of anything, I need to decrement my end pointer, right? And in case of s equal to 1 and end equal to 0, then also I know what to do. So don't you think I've covered all the cases? Basically, the cases for s and e could be 0, 0, 0, 1, 1, 0, and 1, 1. Do you agree on this? That these could be the 4 conditions. Hello. Yes. Oh, yes, will go. Anyone? Right? So, see it according to my approach. If s is equal to 0, I don't care. I will move s forward, right? So this condition is taken care of. Is s equal to 0 and end equals to 1, I don't care. I will move my s forward. So this condition is also taken care of. If s equals to 1 and end equals to 0, I will do this, right? Basically swap s and e and move s forward and e backward, right? And if e is equal to 1, right? Then in that case, I will move back my end pointer. So all 4 conditions are met using these 3 approaches. Does that make sense? Any doubts? Any doubts, guys? Any doubts? If there are any doubts, please ask. Let me just reiterate what we have happened. I said that, you know what, after sorting, my array would look something like this, that a bunch of zeros after a bunch of ones, right? So I said that I will assume 2 pointers at ends, right? And I always will try to maintain this, that everything between 0 till s minus 1 is a 0. And everything between e plus 1 till n minus 1 is a 1. Right? In a non-sorted array, that is the input that I'm given, right? And based on this, I will perform these 3 operations. Does that make sense to everyone? Any doubt up till here? Anyone? Okay. So if that is clear, let's do a dry run now. So we have 1, 0, 0, 1, 0, 1. We have an array 1, 0, 0, 1, 0. What was the array? 1, 0, 0, 1, 0, 0, 1, right? This is our array. I am saying initially start is here and end is here, right? So my assumption that everything till s minus 1 to 0 should be a 0 is fulfilled, right? Because s minus 1 is out of range, so I don't need to consider for that. True or false? Tell me, true or false? True, yeah. And my condition that e plus 1 till n minus 1 is also 1, right? Because e plus 1 is out of range. And I said out of range, I don't need to consider at all. I don't need to be concerned. So this is also true till now. Right? So now let's see what we need to do. I said if e is equal to 1, what I need to do? I need to decrement my e pointer. So that is what I will do. I will decrement my e pointer and my e pointer comes here. Right? Now you have s equal to 1 and e equal to 0. What do I do? S equal to 1, e equal to 0. I swap both of these and increment and decrement the pointers respectively. So I swap these. So let me write it with another color. So this becomes 1 this becomes 0, right? And then I will increment the pointers that now S is here and E is here. Any doubt in this? Any doubt in the operation that I did? Right? Now, again, let's check if my assumption is right now also true or not. I said everything behind S should be a 0. Is that true in this case? Yes, it is. Everything after E should be a 1. Is that true in this case? Yes, it is. So my assumption still holds true. Okay. Now I have S as 0 and E as 1. What do I do in this case? I say that, you know what, if S is equal to 0, then increment S by 1. So that is what I will do. So now my S comes here, right? Again, S is 0. What do? I basically increment S by 1, right? Now it is here. Now S is at 1 and E is at 1. What do? When E is at 1, I just decrement E pointer, right? So now E becomes here, right? And this, when E becomes less than S, that is my termination condition. That, you know what, I only need to solve till here. So now you can see that my array is actually sorted. My array, final array is 0, 0, 0, 1, 1, 1. So this was sort of a dry run for you guys. Did this dry run make sense? Is the algorithm clear what we are trying to do? Before this terminating condition, there was no point when our assumption that till 0 till S minus 1 would be a 0 and E plus 1 till N minus 1 would be a 1. We never broke it once, and I proved you every step of the way. Is the approach clear now, guys?
Yes, it's clear. Like we understood the logic and the algorithm. But the thing is how we come with these assumptions. Like, is it through practice we get through this,
Okay.
like after us? Yeah.
Yeah, this is a very interesting question, and trust me, it is the right question, right? So this is your first class, right? In first class, neither I nor any instructor in the world will expect you to come up with algorithms on your own. This problem solving, and I'm telling you this in as true as possible, this will hit once after a threshold, and that threshold is different for everyone. This is basically coming up with approaches and problem solving, comes up with practice and time. And the only thing that you can do here is talk with me that, hey, Ankush, I'm thinking of this. Can you tell me why it is wrong or right? Hey, Ankush, I'm thinking of this. I can do this. Without using technical words, just pure problem solving and speaking and communicating. That is how you can build your problem solving skills. This, intuition and how we come up with the approach, that the approach will always come from observations, right? And observations will be built when you solve a lot of problems. And in each problem, you're not trying to cram it, but you're trying to understand it and practicing more. That is the only thing, right? So in cricket, when Virat Kohli hits a 6, he does not have to think that, oh, what shot I'm going to hit. It's intuitive to him. That is the same here. Like you have muscle memory, you also have your brain memory that, hey, this looks like this, I'm going to do this. So whenever now, when you see this type of problem, you will think of pointers that, hey, maybe I can do this, I can make some assumptions, and based on the assumptions, I have to hold them true always, and I can go forward like this. So I hope this was, I guess, insightful.
Yes.
Yeah, Mehek.
This approach is only used for 0-1 unsorted array, or is it used any unsorted array?
No, so basically this approach specifically works only for 0-1 array, right? Because our assumption is that we have a bunch of zeros in the starting and a bunch of zeros at a bunch of ones at the end. Okay. Do I need to repeat this for anyone? Basically the approach, observation, or the dry run? Anyone? Is it clear? Can we move to code? Can we move to code? Tell me, do let me know. If anyone wants me to repeat, please feel free. All right. Let's move to the code now. Okay. So I hope my screen is clear. Oh, sorry, my screen is visible. All right. So let's take an array, right? Const ARR equals to 1, 0, 1, 1, 0, 0, whatever, right? Okay, so my length would be array.length, right? and my start pointer would be initially at 0, and my end pointer would be at length minus 1, right? And I'll do it for start till length end, right? So while my array of while s is less than equal to e and my array of start is equal to 0, right? Irrespective of the value, I can say that what s plus plus, that increment my s pointer forward, because it holds true under my assumption that anything behind s is 0. So I can move my s point forward. While my s is less than equal to e and array of e is equal to 1, I can move my end pointer backwards. Again, why? Because I am assuming everything after e is a 1, right? And now while s is less than equal to e and array of s equals to 1 and array of e is equal to 0, I need to swap these, right? So array of s should be equal to 1, 0, and array of e becomes 1, right? And then I can increment start and decrement end pointer, right? And then let's try to log our array. So let's see. So it did not work. Let me check why. Let's try to log array in each iteration. What is happening here? And so did I pass? It only ran once. Okay, why is that? Array of s. Let's log the value of SME as well. What happened?
The
It is not running.
length. Array dot length.
Oh, okay, got it. Yeah, okay. Let's catch typo. I'm sure you are familiar with those. Yeah, so we can see our array sorted. Let's try for another test case. So we can declare another array. So let's say 1, 1, 1, and 0, 0, 0. So again, we got 0, 0, 0, 1, 1. Let's try adding more elements. So 0, 1, 0, 1. You see, again, it works fine, right? So can anyone tell me why we are doing this in each instance? Okay, above I know that because I want to solve for start till end, I'm using this here. But why in each while loop, I'm doing this before the AND condition? I'm here also checking, here also checking, here also checking. Can anyone tell me?
I mean, maybe there will be some sequences correspondingly where multiple zeros at the same place. Maybe some sequences of elements should be of the same. So we instead of going to the next iteration, we just reduce them in that case. Let's say if 3 zeros or 3 ones are at the same place, instead of moving.
May I?
Yeah. So what was your name? Who just spoke?
Pavandeep.
No, the other guy who was just speaking.
This is Charan.
Oh, okay. Sorry. I'm so sorry. It will take us some time to recognize your voices. But Charan, what you are saying is true for why we are using while loops. Instead of going one by one, I'm just collectively doing that, right? I am asking why are we checking s less than e here always?
Yeah, that's a main termination. That's a main termination case, no? If it crosses that.
That is one of the reasons, but that is not the prime reason why we are doing that. We can handle what you are saying by other ways as well. But yeah, Nabhan wants to speak. Go ahead.
The very basic assumptions what we have assumed is before s all will be 0, and after e all will be before s all will be 0 and after e all will be 1. By the time, assuming this is true, by the time s will reach e, to the array is sorted. So we need some conditions. It shouldn't cross it.
I mean, crossing. Sorry. Oh my. Sorry, man. He got stuck. Yeah. Though both should not cross each other, that is being handled by this right here and this one right here. Can anyone tell why during implementing this s pointer and e pointer, why have I put this one here? Okay, Chandani and one more. Dheeraj roses on first, so you can go first. Dheeraj?
Okay. Since inside the while loop, in the first while loop, like we have already checked, but we are checking again and again because our H pointer and E pointer are getting incremented or decremented. So we need to check before going to the other while loop. We need to check because these all incrementation and decrementation is happening inside the while loop only. Okay. So that's why we have to make a check.
I mean, we can handle it. Like, I think that check, you're again saying that you're checking if these don't cross each other. That check can be done by this as well, right? There is a specific reason that I'm looking for. There's a specific answer to this I'm looking for. Chandani, would you like to try?
Hello.
Yeah.
Actually, what Dheeraj has said was almost the same, but just one more thing I would like to add here is, as we know that E will always be more than S, so we have to keep E on the right side. So that's why we are firstly comparing in order to validate the current state of the S and E.
Yeah, but again, that can be done by this above thing as well. Anytime that S and E are not here, they can simply this above loop will terminate, and you will simply hit long, right? Bharat, would you like to try?
Like we are just checking if it is already sorted and making iterations faster pace. Like we are moving ahead.
That is why we are using while. Like the reason they said that is the reason we are using while instead of an if, right? Because if there are a bunch of zeros, I want to skip them one at a time, right?
Yes.
Right. So that reason is okay. Again, that if I replace this with if here, that would also work. The code would also work, right? There is again still a specific answer I'm looking for. Some Nabhan, I guess someone. I'm sorry if I'm pronouncing your name right. Nabhan was it who rose his hand and didn't speak?
Yeah. I think it's basically to check like the next iteration does not, like when you're going through the next iteration, and if the condition was matched in the previous iteration as well. So before moving to the next iteration, you should check that condition again and then only go into that loop specifically.
Yeah, closer. Raviraj, would you like to try?
Yeah, not sure, but I guess we want to keep both the conditions. S is less than E and array start is equal to 0. These both are true, then only we want to reduce.
I mean, yeah, that is why we're using while.
Yeah.
Again, not that specific answer. Like you guys all are absolutely correct, but just like 10% short of it. Sahana S. Shinoy, would you like to go?
Yeah. I was thinking like, what if my array is only of 1 and 0?
No, that is the case with right now as well.
So let's say if my array is of only 1 and 0, that's length 2, right? Then yes will at first iteration, yes will be okay at 0 and E will be at 1. And again you are incrementing yes, it crossed. This is already taken care by outer loop. Yeah, correct.
Does this have like empty edge cases?
Does it has to do?
Yeah,
with
this is an edge case, right? So essentially, what can happen is that you know what if you don't put this condition and your S goes out of bound, right? So let's say there are all bunch of zeros, right? And if I remove this condition, then AR of S at some point will be undefined, and it can lead to breaking your code, right? So if I put all zeros here, so let's say 0, 0, 0, 0, 0, right? And remove S from here. So this won't be, because maybe JavaScript is dynamically typed, it won't happen here. But what would happen in your statically typed language? At some point, you know what will happen? S will be out of bounds because we are not checking for S less than E in this loop, and it would break your code, right? If you try this in C++, it will break your code, and that's why we put it before AND condition, because, and note this down, this is a very important thing, AND follows fail first condition, that if this condition fails, it will not check for this condition, right? So to ensure that your pointers both here and here do not go out of bounds, we have to implement this condition, and that's why we do this.
What will be the worst case for this algorithm?
Yeah, time complexity, we are just coming. I'm just coming on time complexity next. But is this condition clear? Why am I checking before checking the value of ARR of S? I'm making sure that both my start and end pointer in the cases are in bounds. And that they're not going out of bounds of the array, not only themselves, but out of the array also. Okay, so let's talk about the time complexity, right? Time complexity. Can I say that, in the worst case, my start pointer, so let's say if all are zeros, what will happen in this loop right here? All my start will come till here and then terminate, right? If they're all ones, then my end will start from this point and come till the starting position, right? So that means that it will traverse the entire size of the array, true or not? If the array is like completely zeros or ones, then either if they're all zeros, then the start pointer will traverse the entire array because of this condition. If the array is all ones, the end pointer will traverse the entire condition due to this condition, right? And it could be that the pointers either meet somewhere in the middle, right? So essentially, let me pick up my let me draw it like this only. So let me draw here. So my start pointer and end pointer represent an entire array, right? I'm sorry, my drawing is a little bad here because I'm trying to be a mouse. But essentially, start is at the 0th position and end is at the last position. So they are at the poles of the array. So after a lot of manipulations, they would meet somewhere in the array where the end pointer would have traveled some distance and the start pointer would have traveled some distance, right? Can I say that distance would actually be equal to the size of the array? Can I say this part? Tell me. If I can't, tell me. I can be wrong as well. I might be testing you guys. Can I say that? Why? Because my condition is S is equal to E. Till that point, I have to run the loops. Only when E becomes greater than S, that is a condition like E and S, and this is the array comes, that is when I terminate my loop. So I can say that combined distance traveled by both my pointers will be equal to N, which is nothing but the size of the array. So size. So that's why the total number of iterations would be big O of N, where N represents again the size of the array. Is the time complexity clear? Anyone who's yeah, please go ahead.
Yeah, this one, but you're traversing on each iteration, you're traversing again, you're retraversing. So won't it be N into, like, for each, so basically let's say the outer loop plus the number of times the inner loop goes. So each time S is less than E, you're making one iteration, and then till you swap. So how do you put this in words? It's a little hard, but
yeah, but in each case, I won't make an operation. So let's say this is operation 1, this is operation 2, and this is operation 3, right? I won't make an operation if S is greater than E, right? I will only make these operations till S is less than equal to E, correct?
Correct.
Right? So the total number of operations would be equal to the distance that my S and E pointer travel. Do you agree or not?
Yeah.
Tell me. If you don't agree, tell me I don't agree.
Yeah, not just understanding it. So can we, like, in the code itself, can you keep like the number of operations done, like some kind of variable, and then hit +1 for each operation done?
Yeah, that is also a technique that you can use to find the number of operations happened. Yeah. Okay. Cool. Right. Initially equal to 0.
I would like to speak something.
Yeah, please go ahead.
Yeah, Naban is trying to say that basically there is a nested while loop, right?
Yeah.
So
yeah.
I think he's getting confused over there. Key N into N. So basically, what the issue is the accessibility of resource, accessibility of array, which is ideally N only if we are using nested while also.
Yeah.
So I think that is what is.
Got it. So, bro, like nested loops does not always mean that the time complexity will multiply. And why it won't multiply is because here we have written this condition, right? They say it's not happening that each time for each s less than e, this is happening because these s here and here and here are all same. So they're updating every time, right? And you can see here also s, the total operations in this case turned out to be 5. And our length of the array was 0, 1, 2, 3, 4, 5, right? So one thing also I would like to say that this could have come as 4 or 5 or 6 as well, right? Some plus minus could have been there. But as I said that even n and n into 2 or n into 3 doesn't make much difference. So that's why we say that, you know what, the time complexity in worst case would be big of n. Because the distance traveled by the both pointer cumulatively would be the entire array. And they would travel the entire array only once, not again. If you're still getting confused, try doing some dry runs like we did in the on the whiteboard.
Yeah, in the case of all the zeros or all the ones, the first iteration only, it would be terminated. I mean, the outer loop will be break. So the number of operations, iterations will be for the first iteration.
Yeah. Do you have a question? You see, yeah, for like some bunch of mixing of 0 and 1, we got 4 operations, right? So this is like the size of the array is basically 5, and you got 4. So n is equal to n minus 1 in like big O notation, as I told, because if n, 2, and 3 and all are same, so even n by 2, n by 4 are all same as well. This would be more apparent when we, you know, go forward with our course. But is the approach and time complexity clear here? Anyone who is not clear with this, please ask, please. Is it clear, guys? And girls, folks, they, them, everyone. Is it clear? Okay, I'm so happy. So I won't let you go barehanded. I have a gift for you all. So you have a homework problem. That is, now you have to do sort 0, 1, 2, right? I'll give you the problem statement as well. Sort 0, 1, 2. Right. So I'll put this in the chat. Try reading the problem statement here. So I'll just remove my solution. Yeah. Try reading the problem here. Basically, it states that now you are given an array with 0, 1, and 2, and you have to sort this. So think about what we just did and how we can solve this problem using the same approach, right? In terms of pointers, in terms of assumptions, how we can solve this. So this is a homework for you guys, and this platform is LeetCode. Please, everyone, make the profiles on this. This is essentially an online jet where we have a lot of data section and accordance problem, and you can solve the problems here, right? So this is your homework, and please make a account here. Here, basically, it gives you a function that you have to solve with an input, and this is the platform, right? So a bunch, you would see on LinkedIn, a lot of people solve these problems. I personally have also solved like 356 problems here. So it is like a Bible when you are preparing for your interviews and all that stuff. So do make an account here. Any doubts? I'll also paste the platform link. Yeah. Okay, guys. Any doubts up till now? Anything? Anything you want to ask me?
Hi, Ankush, Raviraj here. Yeah,
Yeah,
not related to this particular like course. You just mentioned the LeetCode problems. So are you going to cover the problems from LeetCode only? So like it will be easier for us to track there. Like, is that the case?
So primarily 99% of the time we will do LeetCode problems only. 1% of the time I might like to introduce Google problems or basically Code Studio problems or some other platform problems. But 99% of the time we will do LeetCode only because it's like a Bible for your DSA preparation.
Yeah, I mean, like it becomes helpful now. So like
I completely agree with you. Yeah. And LeetCode is actually the most prestigious worldwide. So we are all clear there. It's the best platform there is. Period.
Yeah, okay. Yeah. Thanks.
Yeah. So that was it for your session today. I really hope you had fun. I really someone asked me. I'll tell you after the session. But okay. Let me wind up. So in this session, we learned about data types, data structures, algorithms, time complexity, and then we solved the problem, right? So I hope you all had fun. If you have any feedback for me right now, please feel free to mention it. Or if you won't like that, if you like to privately do that, you can do that as well. I hope you enjoyed the session. I hope you learned something new, and I hope to see you all in the next class. And Vineet, I am a gold 1 on Valorant, or gold 3, like, yeah. Your lead code profile. Where do you read my lead code profile? I can share with you. Like, it's, I guess, Ankush08, something like that. Yeah, I can share it with you, but it won't do any good. Let me check. Leadcode.com. Ankush. User. Wait, let me check if I have done something. I don't think. I have written a bunch of good articles there. You can give them a read if you want. But yeah, that was it from my side. If you have any doubts, please feel free to stick by. If you have any doubts about the course or about me, or you want to introduce yourself, please feel free to please stay and feel free to introduce yourself. Else, technically, we are done with the session.
Hi, Ankush.
Thank you, everyone. Yeah.
Dheeraj is writing. Actually, the approach which I told you earlier, I tried to code it on Code Studio. Like there is some problem, sort 01. Okay.
Yeah.
So I don't know. Their constraints are test cases 2 raised to the power 2 and n value is 2 raised to the power 5. So maybe my approach is failing on the time complexity, but it is running, I guess. I don't know what the issue.
Like for
So
time limited, are they showing TLE?
they are giving TLE, but so this is the code.
Nah, bro, this looks like linear for time complexity. Wait, after else j++, try adding I++ and j++. Because, okay, that's the decision point that you make. So if you're not doing any operation, do you see what is wrong with your code? In your while, you have an else if, and else, right? So your code will run if the else case will always run, right? So what might be happening is that your I pointer, so you can see from your code that your j pointer will always move forward, right? But there might be a case where you actually need to move your I pointer, but it is not moving. Hence, it is getting stuck in the loop, and hence you are getting TLE. So you need to debug that. Why is your I pointer getting stuck? So the TLE that you're receiving is because of that, because your I pointer is getting stuck in some place.
Maybe I need to put a check on array of j. Maybe.
Sure, you can do that. You can do that, of course. But I feel like this might fail. But yeah, you can definitely try. And if it works, do let me know.
Okay.
Obviously, to solve a problem, there can be multiple ways, right? I just told the way from an observation to intuition, but you can go the other way around as well.
Yeah, the approach you told me that was in my mind earlier, but Sharon told this approach, I guess. So I thought there may be some changes and it will work.
Sure, sure. All right, guys, any doubts? Anything you want to ask me? Anything you want to tell me? That's cool. We need to play once. Yeah.
Okay, guys, if we're done with the session, if you guys don't have any doubts as of now, you can also hit Ankush up on Slack. I think you're there on a Slack community, Ankush, right?
No, bro, not right now.
Okay, then I'll make sure you get added.
Mhm.
So yeah, thank you for the session, Ankush, and
Yeah,
thanks
thank you.
everyone for joining.